Hi students, today I am going to explain the concept of DES, the Data Encryption Standard. Already we discussed the concept of the modern techniques. The modern techniques are applicable to encrypt the binary data. In cryptography, there are two different techniques are there. One is the classical techniques and second one is the modern techniques. Under these two are a conventional crypto system. A conventional crypto system is a single key is operated on both sides. Now whatever the keys are derived, so we can derive from the a single key only. So in the classical techniques, all the techniques are encrypted the textual data, that is the alphabetical data. And coming to these modern techniques, the modern techniques are applicable to encrypt the binary data. So the binary data starts with the 8-bit block, that is by the SDES, 16-bit encrypted data, that is by the Feastal cipher, and from 32 or the 64-bit data encrypted the data encryption standard. So now we can consider this is the 64-bit encrypted data is operated by the DES. A data encryption standard is the procedure to follow to encrypt the 64-bit data in the different pattern. So here the 16 rounds are there. So the 16 rounds are nothing but each round specify the different equal functionality of each and every round. Now we can observe the general description diagram of this DES. Here you can observe in this there are divisions, there are different divisions are there. The first one, the initial permutation is taken. So we already know the concept of initial permutation in the previous sessions. The initial permutation is a permutation. We can arrange the given plain text in the different order. Different order in the sense we can change the position of the elements. Suppose plain text message is 1 to 0101. So we make it arrange the 0101 into 1010 in a different order. That means we can change the position of the bits, but we cannot change the data. So that is the initial permutation. We can apply the initial permutation as an initial stage, and after that we can apply the round function. So that round function is taken the 64-bit plain text data. So we will discuss what the round function in the continuous manner. And second one, we can apply the 64 output of round 1 is applied to the round 2 data. And again we can apply the round 2 output data is applied to the round 3 output data. And so on we will continue until the last round, that is the 16 round. Here you can observe 16 rounds are defined. So here you make it very clear here. So the round 16. The round 16 in the sense the total number of rounds of DES is 16 rounds are taken. Here you can observe the 16 rounds. So the last round is the 16 round. So we will discuss each and every round is a one particular functionality. And after that you can observe apply the 32-bit swap function. So what the 32-bit swap function is, divide the data into the 32 bits are taken. So we can swap the left side data to the right side and right side to the data to the left side. So this is the swap function. So that is the 32-bit swap. So after that we can apply the inverse initial permutation. So that is an inverse permutation is there. So inverse initial permutation is taken IP inverse, that is in the form of the IP. Now so here IP is the initial permutation and IP inverse is the, this is the symbol, IP inverse is the inverse initial permutation. So we know that the initial permutation or the permutations are make it arrange the given plain text into the different order. This is the encryption pattern of the DES. And in every algorithm should be divides into the two categories. One is the encryption and decryption process, and second one is the key generation. So the key generation is plays a prominent role in the block cipher, that is modern techniques. Here the block data is encrypted, so automatically we can take the key generation as the separate one. Now here you can observe the key generation in the second part. This is the right side of the part you can observe. So these all are the key generations. Now you make it identify this key generation. So first we can consider only the 56 bit data is taken here. Now this is actually in the cryptography, whatever the size of the plain text data, we should take the that size of the key size. Otherwise we can't encrypt the data. So the equal number of bits are taken from the plain text, and similarly as well as to the key size. Now the 64 key size is taken actually. So in the using of the permitted choice 1, then the permitted choice 1 derived here the 56 bit, you can observe in the diagram. So the 56 bit is taken from the permitted choice 1. In the initial one, only the 56 bits are taken from the 64. So what about the remaining bit? So in what bits we can delete it from the 64? That is, we make it arrange the 64 data into 8 by 8 order. That means 8 rows and the 8 columns. So that is 64 bits is taken. 64 bits are taken. The last bit, that means the last column bit is deleted. That means the last column is deleted. 8 bits are deleted. Remaining 56 bits are taken as an input key order. So why we can eliminate the 8 bits or nothing but, so in the cryptography, one of the technique is here used, that is a parity check. A parity check is nothing but we can eliminate some few number of bits from the given plain text for error correction and error detection. So whenever the user verifies the plain text message with the help of the parity check bits which are eliminated from the plain text message. So that's why the 8 bits are eliminated. The remaining 56 bits are taken. That 56 bits are taken, that is applied to the initial permutation. Here you can observe. Here you can observe the initial permutation. So the initial permutation is taken the 56 bit data, and the next one we can apply the left circular shift operation. So the left circular shift operation is a different operation, so which make it identified the shifting operation. Suppose for example 1010 is the bit. What the left shift operation? This left side bit data is added to the right side. So the data becomes to the 0101. So the data will be changed 0101 when we can consider to the left shift operation. Similarly, the left circular shift operation is applied, and we can shift it some number of bits to the right side. So that data is taken the 56 bit data, and again the 56 bit data is applied to the permitted choice 2. Then the permitted choice 2 again eliminates 8 more bits from 56, then it will be converted into the 48 bits. Here you can observe. So the 56 bit data is taken here from the left circular shift. In the permitted choice 2, it takes the 56 bit and it will be converted into 48 bits. So again 8 more bits are eliminated from the 56 bit data. That is finally we can derive the 48. So that 48 becomes to the K1. So the keys are generated. Now we will observe in the key generation, the number of keys are derived here. So how many rounds are there? The 16 rounds are there. So automatically each round takes one key separately. So that's why we can define the 16 keys are here. You can observe clearly. So up to 16 keys are derived here. So that means the 16 keys are derived in this manner. So first we will consider the 56 bit key. So we can eliminate the 8 bit. Out of 56 we can apply the permitted choice 1. Then the 56 permitted choice 1 is applied to the left circular shift, and again the left circular shift is applied to the permitted choice 2. The permitted choice 2 make it convert the 56 bit into the 48 bit, and now that 48 bit is the key one, so that can be applied to the round 1 function. So this process will continue until the 16 rounds. You can clearly identify here the 16 rounds are applied. So and finally we can apply the swap function. Now we will observe this is the key function, round 1 function. So this is the round 1 function. You can observe the round 1 function is totally this one. So this type of rounds are continue up to the 16 rounds. That means This is the first round. The output of the output of the this round. Now I am going to take, this is the output of the first round. Now this is the input of the second round. So in the third block, the second block, round function output is taken the fourth block input, and continue will process up to the 16 rounds. So this is the exactly the single round function generation. Now we can observe in single round, the total 64 bit can be divided into the two parts, that is 32 bit and 32 bit. Left side is the 32 bit and the right side is 32 bit. The right side 32 bit is taken and apply the expansion permutation. Here we can consider the different notations are there. The expansion permutation is the permutation. So we can expand the data from the given to the maximum size. Here is the 32 bit data is taken as an input of the expansion permutation. Now you can observe the expansion permutation is exclusive with K1. So here you can observe exclusive with the exclusive operation in between the expansion permutation and K. What is the key size? Already we discussed the key size is the 48. So when the exclusive or operation is taken, the key size is taken the plain text equal size. So here that's why the expansion permutation can be derived the 48 bits. How it can be divided the 48 bits? The 32 bit are taken the expansion permutation input data and is converted into the 48 bit data. So that 48 bit data is exclusive OR. So that finally it can be derived the 48 as an output. Here you can observe. So that means it is very clear, whatever the key size is taken, the plain text is also taken the same size. Here the key size already we derived the 48 bits. So the expansion permutation takes the 32 bit and will be expanded into the 48 bits. So that is the different permitted choice by the user. So now the 48 bits are taken the substitution boxes. Now you can observe here the S boxes, substitution boxes. So this is the very important concept in the DES. Now here you can observe, so the substitution box takes the 48 bits, and what are the bits are derived? 32 bits are derived. Now you can observe 48 bit is taken as an input and only the 32 bit is derived. How it can be reduced the 32 bit? Now you go to the substitution boxes. Now the 48 bits are taken as an substitution boxes are an input, and here the 48 bits are taken and 32 bit as an output, that is derived. How it can be derived? The 48 is divided into 8 blocks. Each block contains the equal number of bits, that is the 6 bits. And it can be derived what number of output each and every block is the 4 bits. 4 into 8 equals to 32 bit. That means the 48 bit is taken and converted into the 32 bit. So in what way it will be the converted? This is the very important concept in this DES, because of suppose the bits are 1 0 1 0 1 0. The 6 bits are taken as an input. So the first and last bit will treat as row, that is first 1 and 0 will be treat as row. The middle 4 bits will treat as the column. The middle 4 bits are 0 1 0 1, that is the column. What is the value of 1 0? 1 0 value is the 2. And what is the value of 0 1 0 1? Its value of 5. That means the second row and fifth column. Some of the substitution boxes are derived by the user which size of the 64. 64 in the sense 4 rows and the 16 columns. So that is the 16 into 4. So that means 16 columns of data is taken. The 16 columns are taken and 4 rows are of the data. So 4 into 16 order. 4 into 16 order in the sense that is the 64. 64 bit data is taken. So the second row and the fifth column of the data is taken. Suppose if the value is the second row and the fifth column value is suppose 11. So how we can convert the 11 value is nothing but the, so 1 value, so 2 that is 2 value, 4 value is 0 and 8 value is 1. 1 2 4 8. 8 plus 2 plus 1 which becomes to the 11. So the 6 bits are taken here and the 4 bits are derived here. So this is the way of conversion of this 48 bits into the converted into the 32 bit with the help of this particular substitution boxes technique. So the substitution box technique is taken, each substitution box takes the 6 bits as an input and converted into the 4 bits as an output. So this is the way to convert the 48 into the 32 bit. This is the very important. Now you can observe. So in previous, what the expansion permutation bit data is taken the 32 bit into the 48. So this is the way we can take the 48 bits. So basically we can consider this is the original 32 bit data. This original 32 bit data is expanded into the 48. So these 32 bit data is only taken. So now you can observe the last column. The last column is taken in the first column in the different order. You can observe here. The elements are the same in the different order. So the 32 is the last bit and here you can take the first bit and the remaining is the same 4, 8, 12, 16, 20, 24, 28. And the first bit is taken in the first column is taken in the last column. So in the different order. So what is the starting number is 1, that will be put here as the ending number. The remaining is the same 5, 9, 13, 17, 21, 25 and 29. So this is the technique which convert the 32 bit data into the 48. So this is the expansion permutation. So the expansion permutation is looking like this and we can convert the 32 bit into the 48 bit data. So this is the technique of SDS. So we can consider the DES. So DES is an extension from the SDS. So because of SDS is encrypted only the 8 bits, but here the DES is encrypted the 64 bit data. So each round is taken. This is the process. This process will continue until the 16 rounds. The 16 rounds are applied here. So and finally we can swap the data. And finally we can apply the inverse initial permutation. We get the plain text message. So similarly in the decryption we can apply the reverse order of this particular encryption process and finally we get the plain text. So the DES is very difficult encryption pattern because of it provides more security, because when we transmitted the ciphertext message to the destination, so how many times are encrypted here? 16 times are encrypted. It is very difficult to find the plain text message. Because of the 16 rounds or decryption is not possible, because the opponent may not be identified this particular process, even though so what bits are eliminated from the 64. So what type of bits are taken, the 56 bit, again we can eliminate the 8 bits from the 56, again we can that is depends on the user perspective. The user can take the eliminated the 8 bits and finally he can apply. So what elements are deleted from the a given plain text, it is very difficult. That is a random choice. So the random choice will never expect the opposite person. Suppose if I am select the number, so the opponent may not be identified what number I am going to I selected, what number I selected. So he didn't expect it, because of that is a random one. Here also similarly the 8 bits are eliminated from the random choice. So how the elements are eliminated, so what bits are taken. So this is very difficult to process, to identify it. So not only that, here the 16 rounds are very powerful encryption pattern. So this is the DES encryption process.